Hello, everyone. Hope that everybody has rested enough, and we're looking forward to yet another study. Today we'll be speaking of trigonometric graphs. Hope everybody's ready and is going to be looking at this with an open mind. So, we're going to be speaking mostly about how to draw graphs, but we have learned how to draw a sine graph previously. So, in introduction, we will be speaking of the general function, which is y is equals to a sine bx plus or minus c, where the a represents the amplitude of the curve, the b represents the frequency of the curve, and the c represents the vertical shift. So when you speak of the vertical shift, the graph is either going up or down. So when we speak of lesson outcomes, we're looking at the objectives and overview of the lesson. So we should actually look at sketching the graph of sine and cosine function by means of what? Amplitude and period method. We should be able to read from the graph the approximate values. Okay, and again, we should be able to combine the two graphs, draw them on one set of axes. If I should put that right. From the previous syllabus, in N1, we learned on how to draw the function of y is equals to sine x, using a unit circle radius method or a table method. So in this case, we continue with that, but on top we are adding how to draw the cos graph as well. So let's look at what we had previously, what we've learned previously. So if you could allow me to get my laser pointer. There we go. So the function that we speak of is sine x. The dotted one there is the one that we have, sine x. Should the sign have been negative, then it would be in the red. All right. And then when we look at the amplitude, rather, again, sine x is the dotted line. Okay. Look at what happens if you change the coefficient, or rather the amplitude of the function. It says 2. So the turning point there becomes 2. Okay. So that's what happens when you change the amplitude. And when we look at the C, which we said was a vertical shift, we would see that the normal graph would be right there. But the minute you start adding it to the function, so you then shift this up. When you're subtracting the 2, then you then shift it down. And the important thing that you guys need to notice is this one. I'm going to write it down. Please pardon my handwriting because I'm using a mouse pad. So when you use this function, especially when you're using a calculator, you're going to do this, put this in your calculator, right? Sine, it automatically opens the bracket, and when it opens the bracket, you put x. So most people do this. They say plus, depending on whether it's plus or minus 2. Then they close the bracket. Okay. And as compared to this, if you have the very same thing, where you have sine, pardon me about this, a mouse is not easy to draw, so it automatically opens the bracket. So you should say sine x, and then you should close the bracket. All right, then you can add the 2. Those are two different things. You should look at that. So what we are talking about here is this one. When we say sine x plus 2 or minus 2, we are actually speaking of the second one, this one right here. Okay, please notice the difference and make sure that you get it right. Okay, so let's say you've been given the function to draw, that is y is equals to 3 cos 2 theta, and they gave you that it starts from 0 degrees to 180 degrees, meaning that's the wavelength, that's how long it will be. Okay, so let's look at that. So in your calculator, or whether you use whatever method that you'll be using, you put on these and you get your values, right? Okay, so the graph would have came out something of this kind. Are we together? So you plot it and it finishes at 180 degrees, meaning at 90 that's half of a graph, and then at 180 it's a full graph. So should they have changed? Now look at this. Remember we spoke of the amplitude, and then we spoke of the wave length as well before we can speak of the vertical shift. So looking at that, it's half. So it says should, in this case I used the period of 360 degrees. So if you look at this, it means because of its half, within the required period you'll have only half a wave. All right, and we call that expansion factor, so which is going to be 2. Now if this would have been 2, it means in this 360 degrees we were going to have 2 waves of cos. So let's start with the vertical shift first. The vertical shift, if this was plus, let's say a plus 2 or plus 1, or rather minus 1, let's do a minus 1 because it's going into the space that we have here. So if we say minus 1 here, it means it was going to start, let's increase that, that was going to be here, that is negative 2, and then negative 3, negative 2, then negative 3. Alright, so this simply says that our graph was going to start there because we minus 1, and then it was going to be like this, finish something of this kind. So let me just redraw that again because it looks very not so right. Okay, let's start with the center, because of now it means that would have shifted as well. It would have been here. That is our period. So this at 180 degrees, that's where it's supposed to cross. Then it was going to be something like this, and then finishes there. Okay, and again, let's another marker. If this should have been 2, rather 2x, and then they say minus 1 still, it means we could have said here at 90 and here at 270. We could have then had 2 waves. Sorry about that. 2 waves that comes like this, turns right here, passes. Guys, you know, technology, we're still learning as well, so we will get it right. We will get it right. So it's supposed to be going in this form. 10 here, that is our breaking point, and then 180 again at minus 1. Then it start again, again at negative 3, then it turns, and then at, so it means within these we will have had how many? 2 waves, of course. All right, I hope everybody's getting the picture of the plus, minus, and the 2. Okay, let's move on. Oh, exactly what I was speaking of previously. You can see they explain it nicely here. Managed to get it with a real drawing, not the one that I did. Exactly what I was talking about. So I'm gonna waste time. You've seen it. There it's happening again. It's breaking up here. It gives us the second wave. All right. Okay. Now looking at these, this is for a cos, normal cos graph. This is a normal sine graph. Now the period t, meaning that the time taken to complete the cycle, we can say, how do we determine the period? We say 360 divided by, right, the b, because in this case the b is 1, so it will be a 360 range. Let's say you've been given this and they say determine the following on your graph. Firstly, 3 cos 2a equals to 0, 3 cos 2a equals to 3, 3 cos 2a minus 1 equals to 0. Then they want to know the period. They also want to know the amplitude, including the frequency. So looking at this, to answer the first question, we look at the point on a graph where this is equals to 0. All right. So you would see that y is equals to 0 where here 45 and 135 degrees. Okay, so that's the reading from the graph. So it will be at A and B. And the second one, where it is equals to 3. So if we look at this point, there's a 3, and there is a 3 as well. So it will be what? C and D. And then again, where this is equals to 1, what did we do? We manipulated this to equate everything to 1. So you're going to draw your line at 1. Wherever it touches the graph, you come down. Okay, so you will have come down from this point all the way down. Read from the graph. So yours will be accurate because you'll be using a graph paper. Sorry, it's supposed to be here. Then you go down. So yours will be accurate because you're supposed to be using a graph paper. You read those values there, then you give those. All right, when we speak of the period, we said the period was 180, isn't it? Okay. So the pattern repeats itself every after 180 degrees. That's the period amplitude. It's how high. We said it's 3. Okay, we've seen it from the graph. I will try and put a slide with the whole information again. The frequency, we said it's the pattern repeats twice within 360 degrees. Okay, there is the slide. The first one we said the period 180 degrees. So you can clearly see that, speaking of this point on the graph, all right. The second one is the amplitude, how high. So it's the maximum point is 3, and this side is minus 3, so the height is 3 either way. Okay, and lastly, we spoke of the frequency. So it means if we have to extend this, this will have repeated itself. It repeats the pattern again. So it will be 2 times every 360 degrees. All right. So, well, you'll just have to double this. Remember, if you say 2 times 30, 2 times 60, so everything will be doubled. All right. So I guess you get the picture of what is happening. Okay. All right. That is the end of our lesson. Please go and do examples. I'll give additional supporting tasks on the portal so that you get used to how to draw different types, or at least also how to read from graphs. Okay, I hope everybody gets the what's happening and enjoy the lesson. Thank you.